By the alternating series test, the series converges. First of all, let's just quickly talk about that. It is an alternating series. We see the negative 1 to the k plus 1. And if we looked at the limit as 4 over k times k plus 4 goes to infinity, fixed numerator, denominator going to infinity means that the terms go to 0. So by the alternating series test, yes, this does converge. We need to find the sum, but first we need to find the partial fraction decomposition. So let's do that. And so we take 4 over k times k plus 4. We put it equal to two partial fractions, one with k and one with k plus 4. So we'll call those a and b. And so if we cleared that of fractions, we'd have 4 equal a times k plus 4 plus b times k. So if we let k equal 0, we will have 4 equal 4a, so we know that a equals 1. And if we let k be negative 4, we'd zero out this term and we'd have 4 equal negative 4b. And so that means b equals negative 1. So our partial fraction decomposition is 1 over k minus 1 over k plus 4. So that's the first thing we would answer here when it asks for the partial fraction decomposition of this fraction. And now if we were to write out the terms to this series, we would first of all we'd put in, I'm going to write out the terms of this series right here, which is this one, and then I'm going to add the alternating piece in just a minute. So first thing I'd want to do is we're starting with a 1, so I'd put a 1 in, and I would get 1 minus 1/5, putting a 2 in, plus 1/2 minus 1/6, and then putting a 3 in, 1/3 minus 1/7, putting a 4 in, 1/4 minus 1/8, putting a 5 in, 1/5 minus 1/9, putting a 6 in, 1/6 minus 1/10, and then we would have the kth term minus the 1 over k plus 4, and then it would keep going. Okay, so as we look at this, we see that it is telescoping, and we will have some terms that will cancel, but I need to add the alternating series part. And so this was the terms that came from putting a 1 in, and we see if we put a 1 in here, we would have times a positive 1. So we're going to leave those alone. But when we generate these next two terms, that would be if we'd put a 2 in, which would be negative 1 to the third, which would make them negative. So I need to change the signs of these two. And then the next term would have a times a positive 1, the next term times a negative 1, the next two terms, because that's what comes from breaking that down. And then the next ones would be positive, the next one times by a negative, and so forth. So now when I look to see what happens as we are going towards infinity, this one would go to 0 and this one would go to 0. And I see that starting here with the negative 1/5, there's a positive 1/5 to cancel with that, and the plus 1/6 and a minus 1/6, and there's a minus 1/7, and if we'd have written the next term, that would have had a plus 1/7. And so all of these are going to cancel except the negative 1/4, the positive 1/3, the negative 1/2, and the 1. So this is a telescoping, and I need to sum up those four terms, and in the problem it says to give the answer as a reduced fraction. So I would want to get a common denominator for those terms, and I'm kind of out of room, so I'm going to do it right here. I'm going to make a little box and put those in it. Common denominator between 1/2, third, and fourth is 12ths, so that's going to be 12/12 minus a half, which is 6/12, plus a third, which is 4/12 minus a fourth, which is 3/12. So it looks like we've got 6/12, 10/12 minus 3/12. So the sum is 7/12.